A particle is projected with a speed u at an angle theta to the horizontal from the ground level as shown in the figure. Now assume another particle is there and it also projected with the same speed but different angle. And angle was 90 minus theta. In that case, what is true? Time of flight is same, the height maximum is same, or the horizontal range is the same, or all the three quantities are different. So what is your answer? So let us visit to this in the video. Okay, so we are today dealing with the time of flight, maximum height and range, and the relation among them, which is the one of the special case for the projectile motion. So let us start with a small bit of a recap what we have done already. So there we have the feature element. We have talked about all that. So we know the terminology what we have there. So we know the horizontal range is what is the range of this one. The what is the time of flight? The total time taken for the flight in the air, and what is the maximum height? The height in the middle of that is h. So it is the highest point where the velocity becomes 0 along the vertical. And all this we have dealt with the motion under the gravity with the vertical upward and downward cases, as well as when we get the informal introduction with the projectile motion. So if you have not seen those videos, please visit so that you can understand this thing in the very clarified way. So I'm just recapping all the things. What is projectile? Is the object which is thrown. Trajectory is the path covered by the projectile. And you know there were some kinematic parameters which involve the velocity rules. We know the velocity along the x-axis means horizontal velocity will remain uniform, while the vertical velocity due to acceleration due to gravity will be remain in some fluctuation, some changes will be there, and these changes make the everything about the projectile motion. So we have the two equation of the kinematic equation was there b equal to u plus gt and s equal to u minus half gt. So plus or minus I have put the both thing depending on the situation how this g is behaving with the other parts. So we all done this one thing. So no need to recap much. Now, as per the problem, we know that there was some angle theta, which is called angular projection, and body is thrown with some velocity u with an angle theta, and it has two components, ux and uy. Ux is the horizontal component, and uy is the vertical component. So, as this body will move somewhere, the horizontal component and the vertical component will vary, as well as some angle of the resultant will also vary, and the particle will move tangentially about this trajectory. So one of the things that x, y, and t is there. I have earlier in the video I have used xi, yi, and ti to show that it's arbitrary point. But you know it's arbitrary point, so there is no need to write the script again and again. So I'm just putting it x, y, and t. It's equivalently good as per the Einstein model of writing subscripts. So what you need to do that we have the coordinate x, y, and t, and naturally you see when the body will move, this ux component will remain the same, but this will vary, as you can see in this case. But you know we have done all the cases of how to find the x as well as the y in the last video of where we have talked about why it is parabolic, and we come to know that when we set the equations, we go to the result that it is a quadratic equation. We show that trajectory is a parabolic. This trajectory is containing a quadratic equation, and that's why it is general relation of a parabola, and hence the trajectory is parabolic. So we all have done this thing in the previous video. So if you have not seen, then please visit there to get more about that. And to me, this relation is important because this is well resolved there right now, not in this expression. I will use this expression now. What you can do basically to drive the parts, you can use from there too. But as you know, I have done this thing, so I will start with here. But one of the important scenario come to know about that time of flight, range, and the maximum height. So let us see how the particle reach at the maximum height. So when the particle is going to reach at the maximum height, what will happen? You can see this is the maximum height. What is happening there? This is going to be vanish. So there is no vertical velocity, only horizontal velocity you have. And this is your maximum height point, right? So we write it at this point, y becomes h. And you know, this part, the complete range, the horizontal distance traveled is called the range. So by symmetry, this range will be half if symmetrical relation is there, and time will be t by 2 because the horizontal velocity was the constant. So to reach the particle independently along the horizontal, if it has thrown not only with the, I mean to say, some vertical velocity, then the half time it has been taken to reach here. And that's why, and the vertical velocity has given its a height. So the time will be t by 2 by symmetry. So you understand that point? So you go to the highest point about the relation. Now, whatever could happen, this would reach at the, I want to say, the last point, which is called last point. It is in this the given problem. Otherwise, in general case or the some complex case, it may be something else. You have to think accordingly there. But as per the pedagogical way, you can understand just there. And this is the symmetrical position where the time is now the time of flight, and the distance travel along this is called the range r. So you know all about that thing. So you know about the what is the maximum height condition, what is the range, and what is the time of flight. So when you are knowing all this thing, so we can move to start to how to get the horizontal range. What is the total horizontal distance covered? So you know all about the coordinates. So we are aware about this is point is 0 0 where everything is 0. We are going to just start the flight. So it's a 0 x 0 y and 0 t. This point you have everything by symmetry half half, and this is the maximum height h, and this is your r range. Y of course is 0, and time taken to cover this one is the capital T. So we want to calculate the horizontal range, so I will use the same relation what I have used for the trajectory part, that y equal to some time. This is along the x-axis. I have taken the time, and this is the time, and other relation you know about that, u sin theta minus g by 2 time. So simply say s equal to ut plus half it square, and ta has been taken out. अगर आपको नहीं समझ में आ रहा, you can use that one also. And this is what y equal to 0. Got it? If y equal to 0, I want y, because at this point this y is 0. So this has to be 0. And now this equation, if you see, has two parts, two factors rather. So one of the factor is x equal to 0. If x is equal to 0, this will become 0. So x will become equal to 0 means this condition. That's not a problem right now. Another situation is there when your this part is 0. Now this is the case that when this is 0, what do you have? You have the range. And the equation can be settled if you do a little bit of, I mean to say, algebra. What do you get? You get u square 2 sin theta cos theta upon g. You understand that this all thing will go there. So you know this relation. Now there is one of the typical thing is that about the trigonometric relation, what you have this one, 2 sin theta cos theta. So about that, you have 2 sin theta cos theta equal to sin 2 theta. So I have a little bit of short about that of trigonometric relation used to be in the projectile motion. You can visit for the shorts there. So you know this thing is sin 2 theta. So ultimately, what do we get? We get the range. And the range what you have is u square sin 2 theta. Simplest form you have upon g. And so this is the range. So y becomes 0 at the two of the point. One point is this one and another point is this one. So at one of the time it is 0, and another time is time of flight. Right? But as the equation has been eliminated t, that's why you get the two condition in the hidden part, you come to know that the another part was the R. So what was R? R was the horizontal range. So you're knowing about all that thing? Now the time of flight. Of course, when you get the R, so you know the horizontal velocity is the constant that you are knowing. This R is knowing, it's known to you, and then this is the horizontal velocity is which is uniform. So you can calculate the time simply. So time should be x equal to ux t. So in this particular case, x become r, ux you know u cos theta, and t is your time of flight. So what will happen? Time of flight will be equal to r upon u cos theta. And R you know, and if you R is known to you, just do something and you get a result of that. T equal to 2u sin theta upon G. Very simple relation, right? So if you're knowing the R, you can estimate the T very easily. So it was the easiest one of the things, but remember the relation. 2u sin theta upon G. So upon G is still there. Now come to the maximum height. So you know condition about that. I have already discussed how at which condition this become maximum height. So again you have to go with the same relation what we have used for the another parts. So there we have used some kinematic relations s equal to ut minus half gt square. So ultimately by using the symmetry relations, we get that this time period will be half. So what will be the time period is given to you, now known to you. So y is to calculate it. So that is h at that particular point. T is known t by 2. So it's a u sin theta by g. Now the 2 is missing there. So what do you have there now? It's h equal to u sin theta minus half g u sin theta by g. And why this relation is there? Why this is there? Because of this relation. You can say u sin theta minus half g, and this is your time. So time you have time period by 2. How much time you have taken to reach there? T by 2. So just place the t by 2. You know the value of t by 2 is the u sin theta by g. And this is u sin theta by g again. So solve it. After solving, what you get? The g by g crosses. This will cross, and that's why it become 1 minus half u sin theta. So it's become half u sin theta. A sin theta is outside, a sin theta is inside. So it's become u square sin square theta upon g, and half 1 minus half is there. So half. So this is the relation what you have. So you got the maximum height. Just you have to do a little bit of algebra, keeping in the mind you are using this relation. That is nothing but the s equal to u t plus half it square, and you get the relations. So this is the one of the things that how you get the relations there. So you got the h. Now you are knowing all the three equations. Now just recall how to remember. So now we have seen all the three parameters. So let us sum up all the things. We know that the range, the horizontal range will be equal to u square upon g sine 2 theta. And then we have calculated the time of flight, which was 2u upon g sine theta. So remember, g is in the denominator in the both cases, and u in the above part. But depending on the dimension of the t and r, you can understand r contain the value of u square, and the t contain the value of only u. Remember, another difference is there is sine theta and here is sine 2 theta, and that is very crucial. Then we come to the height, the maximum height. So when we come to the maximum height, the relation is almost the three parameter in the same place, but here we have square like r, because the dimensionality, they have the same dimension, because this is also distance and this should be also distance. So g is there, the only factor difference is 2. So g and 2. Here it was sine theta, sine 2 theta, and sine square theta. So this way you can recall all the things, but remember that you can replay the role of, I mean to say, the dimension to understand what is the relation. T contain only u, r contain, and h contain u square. While the sine part, which cannot be concluded on the basis of dimension, तो आप याद ऐसे रखेंगे. You will remember like this, that sine theta, sine 2 theta, and sine square theta. So these were the two terms that you have to recall again and again. But one of the strange thing or the very crucial thing what is there, it is your T. If you get the maximize it, what will be the your answer? So when you say maximum, that means sine theta maximum is 1, right? R sine R contain the value of sine 2 theta. So it is maximum when this term equal to 1. And what does it mean? This term equal to 1 only when theta equal to 45 degree. So if you are throwing something and want to reach maximum there, so your angle should be 45, because only then this quantity will be equal to 1, right? Maximum value is 1. So this angle of projection at will be maximum only when you have your angle equal to 45 degree. Let's say this way, like this, 45 degree. And if you throw it by some other angle, smaller or larger, like this one, you have here, this one, or like this one, what is there? The range will be shorter. So you have to think about that, why this is happening. Okay. So this is the one of the critical thing that you have to remember, that here it contains sine 2 theta. This all is happening because of this has a value of sine 2 theta. So in case of maximum, of course, this has to be 1, and your maximum range will be equal to u square upon g. That's nothing I mean to say difficulty there. If you're going to, and the similar cases here, it is also maximum when it is 1. So it is will be 1 means 1 square is 1 again. So this is the cases of when you fall, when you allow to fall it or in the vertical. So that was the not the case of projectile. So we did not talk about this much, because these two cases are not the case of projectile, because when you are throwing a ball up, because what does mean by theta when I say theta equal to 90 or pi by 2? So if I say that theta equal to 90 or pi by 2, that means I am throwing the ball up. So it is up and down motion. It's a vertical up and down motion. It is not projectile, because for the projectile a horizontal distance is necessary. Understand? And that's why these two cases are not meant for the projectile. These are the cases when they are in the vertical fall or upward fall or downward fall. So what you have to see is that only range is there. A range is what? R equal to 2 u square upon g, and it could be maximum when theta equal to 45. So this thing you have to remember, whether you're playing cricket or you're throwing something for a game, your range need to be maximized. When it needs to be maximized, your angle should be perfect. So that is the one of the greatest question of the range about. So now coming back to our original questions, and original question was that, you know that it is projected at an angle theta and 90 minus theta while the speed was the same. So what is your answer now? To get the answer, in the last slide we have seen what is R, what is T, and what is H. You all remember that? I have just recapped that one. The critical thing was that when I replace in the second condition, what you got? 90 minus theta. So you replace that one with the 90 minus theta in each case. You can do. Now there is a sine 90 minus theta is there. This sine 90 minus theta is there. Okay. Here you can again say 90 minus theta, but 2 is outside. Here it's okay, sine square 90 minus theta. So if I do the something with the 2, so this 2 will go inside and it will become 180 minus 2 theta, right? So now I need to know the two trigonometric relation, one for 90 minus theta, another for the 180 minus theta. Now what I got for the 90 minus theta, as it's a first quadrant, so cos will be positive and it will change. So it's a cos positive term, right? But while for the 180 minus theta, pi means 180. Okay. Pi radian means 180 degree. So 180 degree minus theta equal to sine theta itself. So I know the changes will occur in these cases. So what will be the changes? this will simply become sine 2 theta again. So these two relations are the same. So of course I go to one of the things that C is correct option. So C is the correct option, right? Now what about the others? Here it is cos square theta and here it is again cos theta. So while in these cases it's a cos theta and it's a cos square theta, which is in general not equal to sine theta at any case apart from the 45 degree. So what will be the part in that case? That this is of course wrong. What is saying all the three quantity, time of flight, range and height are different. No, we come to know that range is the same, right? Time of flight is the same. No, it's a sine theta, it's a cos, it's a sine theta, it's a cos theta. So it is gone. About the maximum height, it's again cos square theta and sine square theta, you can see. So this is wrong. So only answer is that C is correct. So what is your option? C. Got it? So finally we get the answer in terms of C there. So I hope you understand what is the case of the horizontal range, time of flight, and maximum height. What? So I hope you can do the problem about these three quantities, and this is special part of the projectile. So with this, visualize that one. Now you see the range is the same whether you throw it by angle of or projectile angle theta and 90 minus theta. So you come to know that answer C is the only correct option, and that's all from my side for this video. I hope you know the projectile. Now we will do some of the special cases of the projectile, but that we will do in the different playlist section. So thanks for the learning with Vajas. Bye bye till